Hi, my name's Olivia Hess, and I'm involved with the Neurosurgical Research Clinic at Hershey Medical Center. And today, I would love to be able to give you an elaborate, detailed lecture on the intricacies of how ALS manifests itself in patients. But we have time constraints, and that probably wouldn't help you too much to accomplish the goal that I would like you to today, which is really to develop an appreciation for what scientists do in the laboratory, because sometimes we hear all of these developments and we're like, oh, that's really great, but how does that affect us and where do those things come from? And I've had the privilege to work with some of the most brilliant minds on the cutting edge of science, and so I'd like to be able to share some of my experience with ALS research with you and help you to kind of appreciate what these scientists in these laboratories all over the world are doing. So I'll start by giving some of the basics of ALS. So it's characterized as a severe progressive neurodegenerative disease, which basically means over the period of only really 3 to 5 years, only about 10% of patients will live more than 10 years, you will decline very rapidly in patients. It's a very uncomfortable disease, and it is a terminal illness at this point because there is no cure. We have treatments that can limit the progression of the disease by a few months, but really no significant developments are made so far. So approximately 5,600 new cases are diagnosed each year within the United States, and a large percentage of these patients will die quickly after diagnosis because, as I said, there's really nothing we can do to help them at this point. If you see an ALS patient, and usually they will only get diagnosed after these very significant symptoms appear, they won't be able to move their limbs because your motor neurons are destroyed. They may not be able to swallow or speak. And so all of these side effects will eventually accumulate, and you will develop losing respiratory function, which will eventually lead to death. How we diagnose ALS, it's kind of a battery of tests that are pushed together, and you can kind of create a solid diagnosis because some of the symptoms are similar to Parkinson's or multiple sclerosis. So a bunch of tests such as CT scans, MRIs, nerve testing, blood testing, those types of things, even spinal taps, which aren't particularly fun, are used to diagnose ALS. Okay, this is kind of sciencey, so bear with me for a moment, but I think it's important that you understand these causes for what I'll talk about later. So cytotoxicity refers to an excess of a neurotransmitter called glutamate that destroys your nerve cells. Immune inflammatory is a theory that says if you have a very severe illness, your own cells will attack your body and ultimately kill your nerve cells. And this is the most important one that I'd really like you to keep in mind for later in the presentation, which is called superoxide dismutase 1, which is an enzyme that's actually embedded in a gene known as SOD1. And when this gene has a mutation, what will happen is you cannot metabolize iron. HFE is another gene mutation, but that's kind of irrelevant. But this gene mutation will ultimately lead to what's known as oxidative stress. And so this model will be used in the mice that we do our testing on to try to see if these treatments will end up working. Okay, as I said, there are really no treatments right now that have substantial results on the patient. There's an FDA-approved drug known as Rilitec or Riluzole. And it really has very modest effects on patients, only extending their lives by a few months. Okay, so now I'll tell you a little bit about what I do in the ALS research facility at Hershey Med. So it's, I think, sometimes a misconception of that these scientists have an abundance of money to do whatever they please. But really, it's a very competitive process. And you have to get what are known as grants, which can be given by the government or various health organizations. And research have to submit highly detailed plans, very, very detailed. It's always kind of a joke among the people in the lab. How far are you in your grant? How many times do you have to revise it just because of how technical the process is? So that is where the money comes from. And the grant I am working on is actually funded by the Department of Defense. Okay. So, what does a typical day in the lab look like? Do we just sit and, play with little test tubes and beakers and stare at little slides and that kind of thing? Part of that's true, but a very large portion of our day consists of mice. because ensuring that they are happy and healthy and alive is a very important role that we play in the laboratory because they're an integral part of our testing. So we have a lot of meetings. Collaboration is a very, very important aspect of laboratory research because people in labs across the country, even across the world, can really contribute to something that you might be doing. So we do take advantage of that. Okay. So this kind of comes back to what I was talking about earlier with the gene known as SOD1. And in ALS patients, sometimes you'll find high iron deposition, which is basically you have a lot of iron deposited along your spinal cord, and that can be a problem when oxidative stress occurs because your body cannot properly metabolize the iron. So this is kind of our pinpointed cause of ALS that we are attempting to treat because it rapidly kills your nerve cells, which causes the progression of the disease to be faster. As you can see below, increased motor neuron damage equals faster rate of losing motor control equals an earlier death because your respiratory system will fail to function. Okay, so kind of the big idea that we have that I'll talk about a little later with the mice is that if you're flushing artificial cerebrospinal fluid through your spinal cord with potentially proteins that can sequester iron, which means take it out of the system, one being known as ferritin, which is a natural protein found in your body, that it could potentially give the iron molecules less time to damage your nerve cells, which is, this idea of infusion is very forward because usually we're trying these chemicals and these drugs that really can have negative repercussions on the body itself. However, this is a natural approach by putting proteins and substances that are already in your body to try to combat the nerve damage. Okay, so the official hypothesis: if apoferritin, which is ferritin without iron, and artificial CSF are infused intracerebroventricularly, which just means into the ventricles, which is into your brain, into the ALS mouse models, then the progression of the disease will be slower and the lifespan of the animal will increase. And I'll tell you how we determine these things. Okay, so there's the title. So the mice I'm working with have the SOD1 gene mutation. There are 3 groups in the study. There's the control, which all of the mice have ALS. The control has no pump. One of the mice will receive a pump with just cerebrospinal fluid, and then another with the protein I was talking about earlier. So how do we determine if they're doing well? Do we just see who lives the longest, or do we see who looks the healthiest at the end stage? Well, we have a couple of tests in every aspect of the mouse is used. We use behavioral studies, which include putting the mice on what are known as rotor rods, which is kind of like a little circular treadmill. And we count how long they can stay on and how many times they fall off, which really shows us their muscular endurance in a situation where they have to be moving. There's also another where you can see how hard they can pull and grip on things, so that kind of shows us their strength as well. And after they're determined to be at end stage, we extract their spinal cords and their brain tissues, and we use those for very valuable histological and biochemical analyses. And that's a lot of the bench work that you typically characterize scientists as doing with the test tubes and the beakers and all of that kind of fun stuff. Why must we use mice? Why must we take these warm, fuzzy, adorable creatures and subject them to pain and that type of thing? Well, mice are a necessary model of ALS because it's not like a disease where you can just take a little petri dish of cells, throw in some drugs, and see which ones live and which ones die. ALS affects the entire nervous system. Therefore, it's a very complex model, and you need a complex model to replicate what the effects of any new treatments may have. And especially for ALS research, there's absolutely nothing we can do to extend the lifespan of an ALS patient by years. They are told you will die within a few years. And witnessing the reactions of these patients, as you can imagine, is heartbreaking because it's hard for the neurologists as well because they can't do anything to help these people to stall this painful and very rapid death. So they play a very critical role, and they're very useful to us. Okay, so how are the mice treated? Before I went into the lab, I was very curious as to what it would look like if there would be huge metal cages and little mice scattering around in a dark room. And I was actually pleasantly surprised because they're treated almost like pets. It's a very respectful situation, as It's monitored very closely by what's known as ICUC, and they do not play around with researchers. If any small error is made, then your entire experiment will be thrown out. So the mice are kept in little cages. They have bedding and food and water and even what's known as psychological support, which can be little tubes for them to play in or that type of thing, if necessary. So they're really treated like pets, and we do respect the mice very much because they're very helpful to us, and they're also very expensive. So when it's determined to be endpoint, this is when I have to kill the mice, not me as myself, but my mentor. It's as if when you have a sick cat or dog, it's humane euthanasia. So when the mouse could not groom or feed itself, when it appears to be in an unnecessary amount of pain, basically, we have no problems with humanely euthanizing it, regardless of what it would do to our data, because their lifespans are very important in affecting what our data looks like in the end. Okay, so the question I commonly get, does it make you sad killing mice? Does it hurt your feelings when you have to see mice die? And my response to this is, although I would prefer to not have to have mice die as part of the experiment, what makes me sad is when I see a 40-year-old father with a wife and 2 children on life support who's going to die in a matter of weeks and is in an immense amount of pain, and there's nothing we can do to help him. So research is really what we should be focusing our efforts on right now, because that is how we will save the lives of the patients and give them a higher quality of life. Okay, so is the research successful? Is all of this testing we've been doing really making any progress? And it does appear so far that regardless of what type of infusion you're using, if you are pumping in another solution into the spinal cord of the mouse, it is delaying the disease progression so they can walk for a longer period of time, and they do not die quite as quickly as the mice that do not have pumps. So that's quite promising. And what's even better is sometimes you can find a treatment or a cure, but you really can't use it anywhere. It's knowledge and it's good to know, but you can't use it with patients. And what we've done is we've consulted with the board of neurosurgeons at Hershey Medical Center, and they have verified that yes, this is a treatment we could use with patients if it shows that the results are substantial enough. So that's very exciting. I had the privilege of working with the ALS clinic a bit at Hershey Medical Center, and although it's not really the most cheery or fun situation to be in, it gives you a lot of perspective on why we need to focus so much on research and how much it will end up helping these people, because I can't emphasize enough that it's a very helpless feeling having a patient that you can't do anything for, and they can't really do anything for themselves except wait until they die. So, okay. How does biomedical research impact the world? Well, even as we were listening in that video earlier, she kept citing all of these scientific studies and saying, scientists have discovered. And we get those kinds of studies and those kinds of results from discoveries made in laboratories all over the world, regardless of if you realize where, who came up with these results, or how many people, or how many times it was tested. Research, when you put it together, can kind of give you a good big picture of what's going on. Think of how much more we know about how the body works and how diseases work than we did 10 years ago, 20 years ago, 50 years ago. Science and technology is plays such a valuable role in society, especially in the medical field, because as we find out new things, it really directly affects the lives of patients. And one of the key things we focus on in the lab is clinical application. And that's a big part of biomedical research as a whole, because what your goal is to use what you find in the lab and directly use it with patients. Not just as knowledge, but as a cure that you can use with people, because that's the ultimate goal. And when solutions are found, the best way to implement them is usually researched and determined by a collaboration of both the doctors and the scientists. So next time you hear of a new way we're treating cancer, or a new way to detect Alzheimer's, or even a new food to add into your diet, realize that these discoveries are coming from laboratories all over the world, and it may affect your life, and it may be affecting your life now and in the future as well. Thank you.